Hey boys and girls, meteorologist Steve Caparata back for another summer of Cap's Corner. It's the third year we've been doing this. Today we're going to give you an introduction to weather, and if you've watched this before you might recognize some of the slides I'm going to show you today, but we're going to do some different things as well. I'm going to give you a little behind the scenes look at how we do weather here in the studio, and also going to have some different experiments for you. So even if you've done this before, hang with me. I think I have some new stuff to show you today. So let's talk about what I am. I'm a meteorologist. So if you guys go online, or if you actually have a dictionary at the house, you can look up this big word, meteorologist, and you can find a definition, something like this one from the American Meteorological Society. But you don't need to worry about that big long description. Somebody like me, very simply put, what a meteorologist does is we're somebody that studies and predicts the weather or makes a forecast to let people know what the weather is going to be like today and in the days ahead. Now what I do is I work in TV, but there are many other career paths you can take in meteorology. For example, broadcasting, you can do this, TV, but you can go work for the National Weather Service. They are the meteorologists that issue all the watches and warnings, tornado warnings when we think a tornado might be coming. Lots of jobs with that. You can work for the military. You can work in aviation or for the airplane companies. Planes flying around need to know what the weather is going to be like, right? You can get into research, or you can even get into something like emergency management. There are many career paths you can take in meteorology, with what I do, TV just being one of those. Now right now you guys are looking here, and I have this nice pretty graphic behind me, and so you might think, okay, if I were in studio today with Mr. Steve, this is what I would see behind him. But believe it or not, it's actually a little bit different. Now let me show you something. I'm stepping off here. So we stand in front of something called the chroma key here at TV station. Watch this. Uh-oh. What happened? You can't see me anymore, right? So what is going on? Well, if I give you a look at the behind the scenes, and behind me, we've actually got this green screen. And so the way that this chroma key works is our camera and the equipment is hooked up to some special equipment that takes anything that is painted this color green and replaces it on your TV with the weather graphics that you see behind me. So I have to be very careful. I can't wear green, otherwise I'd look kind of weird. I could have, let's turn it this way. I could be like a floating head on screen, right? So that's how it works for us. Kind of neat to see that little technology behind the scenes, I think. So we use a chroma key, and that allows us to use whatever graphics we want behind us. We can pull up cameras, traffic cameras, all sorts of stuff. Pretty neat technology, and that's what it would look like if you were actually here in the TV station to see what it looked like in person. All right, let's get into our weather maps a little bit. So if you watch any of the newscasts, we will often show you maps that have some of these features. Give me a few minutes and I'm going to run through these and you'll understand them. And it's a really good idea of what's going on in the weather if you can understand each of these features. So the first thing I want to focus in on, these blue H's. Anytime you see a blue H on one of our weather maps, that stands for high pressure. Now, did you boys and girls know that the air around us actually has weight? So just like you can stand on a scale and figure out how much you weigh, we can weigh the air around us, and we call that air pressure. So some days it's higher pressure, some days it's lower pressure. When high pressure is around, the air around us is sinking down to the ground. And what does that mean for our weather? Well, since the air is heavier on those days, we end up with sunshine and overall, generally speaking, nice weather when high pressure is around. So if you see one of these blue H's on the map and they're close to us here in Louisiana, or wherever you may be watching, if it's close to you, generally speaking, the weather's going to be nice. But here's an even easier way to remember high pressure. I like to teach kids that high pressure gives us happy weather. All right, so say that with me. High pressure gives us what? Happy weather. All right, so if the H stands for high pressure, what do you think the red L stands for? Low pressure, right? So if you see one of these red L's near you on the map when we show these on TV, or you can go online and find these weather maps as well, that's low pressure. And when low pressure is around us, the air around us is actually rising up into the sky. So what does that mean? When we get rising air, it's lighter, and we typically on days like this when low pressure is around, we end up with clouds and sometimes rain and thunderstorms. In the winter months, that could even be snow or wintry precipitation. Doesn't happen too often in South Louisiana, but low pressure can certainly help with that. So here's my trick for remembering low pressure. I like to say low pressure gives us lousy weather. Lousy, just another word for bad. So say it with me. Low pressure gives us what? Lousy weather, right? Okay, so there's a breakdown on high pressure and low pressure. Now, I'm about to take you into my home lab with my two daughters, and we're going to go through a couple of experiments, real easy, you can do at home, to see air pressure in action. So here's what you're going to need. For the first one, we need a glass, we need an index card, or something like a piece of cardboard, something like that. We need some water and something to catch that water in, or you can do this by a sink. For the second experiment, we need a couple of balloons, we need a couple of pieces of string, and we need a straw, maybe a little tube, something like that. We can even get away without the straw or tube if you don't have it. So let's hop into my own home lab and check out how you can see air pressure in action in real life. So we're learning all about air pressure today here in the home lab, and we're going to show you an experiment sometimes called the kissing balloon experiment. We're going to see high pressure and low pressure in action right here in the kitchen. I've got a few assistants with me today. You are
Eliana.
And this is
Clara.
Who's this, Eliana?
Thunder.
Yeah, Thunder's going to be kind of our cheerleader here. Let me take Thunder down before we start. So what we've done is I've got a couple of balloons for each person, a couple of pieces of string, or I had yarn in the house, kind of rigged it up here on the island, but however you can hang a couple of balloons down, that should be good enough. All right, I'm going to hold Clara's balloon out of the way. Eliana, you're going to blow some air in the middle of those balloons. Show us what happens. Whoa, did you see what happened there? Wouldn't you think when you blew some air between the balloons that they would kind of come apart, but instead they come together, they kiss. All right, you hold your balloon while we let Clara give it a try now. All right, Clara, let's see if we can get your balloons kind of still, and you give it a go. All right. Started to come together. Let's try it again. Make sure you aim in the middle. So this is a good lesson. You got to get that air kind of right in the middle. There it is. She got the kiss too. So what is happening here? The reason this is called the kissing balloon experiment, obviously the two balloons come together, but instead of those balloons spreading out like you might think, when you blow that air in between the two balloons, you're actually creating a little area of lower pressure. And air flows from high pressure to low pressure. So we're getting higher pressure on the outside of the balloons, low pressure on the inside, and that causes the two of them to come together. Eliana, I'm going to get you to do one more thing. I'm going to pull you over here a little bit. Blow on the outside. Let's see what happens. All right, do it again. See. Do you see how the balloon is coming out towards the area she's blowing instead of going in? It's that same concept. We're actually creating lower pressure right here, and that balloon's going towards the lower pressure. All right, so that's the kissing balloon experiment. Thank you guys, but hang tight. We're going to do another little experiment where you can see high pressure and low pressure in action in your kitchen. All right, guys, here's another way that you can see air pressure in action in your own kitchen. We just swapped sides of our island now to get closer to the sink. If you can't get right by the sink, just do this over a bowl or a piece of Tupperware or something like that, because accidents can happen with this one. So we got Eliana and Clara back, and Eliana, who do you have this time?
Thor.
Yeah, we got lots of helpers in the house today. All right, let's put Thora down, and Clara, go ahead and show. So for this, all you need is a glass of water and an index card. You can experiment with how much water you put in the glass, but Clara, show them what to do. So she's going to put that index card on top, put a little bit of pressure. She's going to flip it over while holding the card to the bottom of the glass, and then she's going to let go with that bottom hand, and voila! Look at that! How cool is that? All right, now, Eliana, you give it a try. So index card on top of the glass. We're going to put just a little bit of pressure with the palm of our hand, flip the glass over, and we get a little spillage. That's okay. And now, let's see. Let go, Eliana. Let go. There you go. So she had a little bit of spillage. We just had to kind of get that card sealed. But so what's going on here? In the glass, while that works, in the glass, there's some air, and within that is lower pressure than what's outside the glass, the high pressure. So that high pressure is pushing up on the card, keeping the water inside, so it's a little bit of a magic trick, but it's also air pressure in action. All right, let's get back to the studio now to wrap it up. Eliana and Clara, you guys say bye until next week, right?
Bye.
All right, see you back in the studio. So what did you guys think? Kind of cool to see air pressure in action around us. There's actually a number of experiments you can do. Look those up with mom and dad if you want. Let's get back quickly to our weather maps. A couple other things I want to show you. So if you see a weather map and you see a blue line with some triangles on it, that is what we call a cold front. And very simply, the name is obvious. You see, this stuff's not so hard. A cold front gives us colder weather. All right, when we have a cold front around, kind of like with low pressure, they give us clouds. They sometimes give us rain, storms, or even every once in a while, here in South Louisiana, not too often, might sometimes give us some snow. Here's one other thing to remember about the cold fronts. The points on the triangles actually tell us which way the colder air is moving. So on our map here, the cold air is moving left to right, or west to east if you know your directions. All right, two more things to show you in our weather maps. We see a red line with sort of these semicircles, these half circles on it. That's a warm front. So if a cold front gives us cold weather, what kind of weather do you think a warm front gives us? Warm weather? Right. Yeah, it's pretty obvious, right? So a warm front, when one of these moves on through, we get warmer weather. Again, they come with clouds, rainfall, and storms often when they move through. And just like the triangles on the cold front tell us which way the cold air is moving, on a warm front, these little circles tell us which way the warm air is moving. So on this one, again, moving left to right or kind of southwest to northeast on that map. All right, one more front to show you. When we get both blue and red, and we get the triangles and the red circles showing up on our map, that's what we call a stationary front. Now, do you boys and girls know what the word stationary means? It means this. I'm not moving, right? Stationary is a front that's not moving. So it's a cold front or a warm front that's just kind of stuck in place, not moving. We still get clouds and rainfall and storms along these fronts. The colder air is going to be on the north side. If you know your directions, the warmer air is going to be on the south side of the front. Let's talk a little bit about storms and in particular lightning. How about this awesome shot of lightning over Tiger Stadium that was taken a few years back? So let's talk a little more about lightning. What is lightning? Lightning is very simply electricity traveling between the clouds and down to the ground. Another amazing shot. This was taken by a gentleman named Frank McMains a number of years ago in Baton Rouge. This is the big bridge over the Mississippi River, but look at that lightning. All right, so let's tell you how lightning actually forms, what puts it all together. So we start out with a thunderstorm, and have you boys and girls ever heard the saying, opposites attract? Well, when we talk about lightning, we're talking about electrical charges, okay? So for the young kids at home, this might start to get a little confusing, but hang with me. So at the bottom of a thunderstorm, we end up with negative charges, electrons, whereas down at the ground, things like trees or power poles, taller objects, we start to see some positive charges gathering on those. All right, so what happens is some of those electrical charges, the negative ones at the bottom of the cloud, start making their way down towards the ground. We call that a stepped leader. As those negative charges start moving down from the cloud, they start drawing the positive charges up towards them. And once the two of these meet, the negative and positive, once they connect, we start get electricity flowing. And what we actually see with our eyes when it comes to lightning is something we call the return stroke. That's actually the electricity kind of traveling back up towards the cloud. And this can happen a number of different times. And then lightning happens very fast. We're going to talk about lightning and thunder, what causes all that in just a second. But just to show you, there are many different types of lightning. What is most common, or what we see probably most often, is cloud to ground lightning. But we can have what we call intra-cloud lightning, that's within the cloud. You can actually have bolts coming out of a cloud into the open sky, cloud to sky. You can have lightning between clouds, and then we can have ground to cloud lightning, a number of different types. All right, so let's do another experiment. What do you say? All right, so this one is pretty easy too. When we talk about lightning, we're talking about electricity. There's static electricity all around us in the world. So this will at least kind of give you an idea of those positive and negative charges, how they work, how you can see them in action. So here's what you're going to need for this one. A faucet, we need some water, and then you really only need one of these things. A balloon, a plastic comb, a styrofoam cup, something like that. And we're going to show you static electricity in action. All right, so let's hop back into my home lab and check out this experiment. All right, so we're just talking about lightning now in the lesson and static electricity. You can see static electricity in this little experiment in your house. So Eliana, she's got a balloon. Go ahead and just rub that on your head. Now you can do this with a balloon, a plastic comb, if you got a wool sock, something like that. But after rubbing it on her head, we're going to take about this little stream of water and look at that. Can you see what's happening as she moves the balloon back and forth? Do you see the water kind of going toward the balloon now and pull it? Oh, there you go. All right, Clara, you go ahead and try it now. I'm going to pull the faucet around. You rub that balloon on your head, and we'll pull it around this way. But you just want to get a small little stream of water going. You don't want to get that flow going too heavy on the faucet. As Clara rubs, all right, Clara, remember, now you got to point the part of the balloon that you've been rubbing on your head. You got to point that towards the water. All right, let's see. Yeah, turn that to the side a little more. Let's see. I think it was like here. Are we getting any? I think we're getting a little movement, just a little bit. So you got to make sure you get that charge built up. So let me tell you what's happening here. Remember, we were talking about electrons and lightning, different electrical charges, negative and positive. So when you rub that balloon on your head, you're generating a bunch of static electricity. And so we're building up a bunch of negative charges on that balloon. And then those negative charges draw the positive charges in the little stream of water towards it. And that's what makes the water bend. That's static electricity in action. Static electricity is at least part of what goes into the lightning we see when we see storms. Look at how much that's bending right there. So give that a try at home and let me know if you guys have any luck when you try it out. Pretty cool to make the water bend like that, wasn't it? Hopefully you guys had some luck doing that at home. So before we wrap up our discussion of lightning and electricity, let's talk a little more about what actually causes thunder. Did you know if you hear thunder, that means there's lightning around? So this is a really slowed down video of lightning in action. So here's our stepped leader. There's the return stroke, the part that we actually see. Stepped leader right here, and then watch. That's the return stroke where we actually see the negative and the positive linking up. So lightning, it heats up the air. It's very hot. It heats up the air around it to more than 50,000 degrees hot. That's 5 times hotter than the surface of the sun, if you can believe it. And since it's so hot, that causes the air around the lightning bolt to expand so quickly, it's basically a mini explosion of air. And it's that expansion of air, that explosion of air that we hear as thunder. So have you ever thought about this? If you pay close attention, most of the time, you should see lightning before we hear thunder. Why is that? Well, let me tell you why. The speed of light, lightning, is faster than the speed of sound. Thunder, what we hear with our ears. So we see the lightning first with our eyes because the light travels faster through the air than the sound of thunder travels through the air to our ears. Does that make sense? All right, so there's even a rule you can use to figure out how far away lightning is. Now, let's say you're inside safely and you see a lightning strike outside the window. As soon as you see that flash of lightning, you start counting. You go 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. For every 5 seconds between the flash of lightning and the bang of thunder, that lightning's about 1 mile away. We call that the flash bang rule. So something else you can use to figure out how far away a storm is. All right, before we wrap up today, let's talk about a couple of the important tools we use in weather. So if you ever get a chance to see this and you wonder what it is, this is a radar, a Doppler radar that we use in weather, meteorologists. This is the closest one to us in Baton Rouge. This is the National Weather Service Doppler radar in Slidell. Kind of looks like a big giant soccer ball on a tower, doesn't it? Here's how radar works. So within that big giant soccer ball, there is an antenna, a dish that's spinning around on a pedestal. And as it's spinning around on that pedestal, it's actually sending out radio waves. Well, as any of those radio waves bounce into something like a raindrop, that's what this graphic is showing, some of that radio wave gets bounced back to the antenna, and then the radar can start doing some math and say, oh, there's something up there in the sky. It can figure out how far away that rain is and how heavy it might be. All right, so that's basically what we're showing here. The radar doing some math on how long it takes from when it sends out that radio wave to get some of that radio wave, some of that energy bounced back to the radar. Now, here's what you might see if you watch us on the news or on mom and dad's phones, on their weather apps, okay? This is a radar loop, a radar movie of Hurricane Ida. A really bad hurricane hit Louisiana last year. So a few things I want to point out as this loops back. We'll let this loop back one more time. But as you look at the colors on this, the greens, the blues, those are generally your lighter rains. Where you get into yellows, oranges, reds, those are the real heavy rains, the bad storms. And then this is what? The eye of the hurricane, right? Okay, within the eye, actually calm, but right around the eye is where the worst of the weather is. So that's what radar looks like in real life. What I just showed you, you've got that big soccer ball up on a tower, big soccer ball looking thing. Once we get all that information, the computers put it into a picture or movie like that. Now, another weather tool we use every day, satellites. So our weather satellites that we use most often, it's a big word. They're called geostationary satellites. What does that mean? Well, this is what that graphic's trying to show. The satellite orbits Earth at the same speed that Earth is rotating. Why is that important? Well, because the satellite is moving the same speed as Earth, that keeps it over the same part of Earth at all times. And once we take a picture of the clouds from up above, we can start stringing them together and actually make a movie. If the satellite was moving at a different speed than Earth, we couldn't do that. We couldn't string those pictures together and make a movie or an animation. So those are geostationary. We launched them out into space on rockets, 22,000 miles up above us. There's another type of satellite we use a little less often in weather, but it's called a polar orbiting satellite. And as the name kind of tells you, if you know a little bit about our Earth and how it's structured, we have the North Pole, the South Pole. The polar orbiting satellites orbit over the poles instead of doing what those geostationary do. So the polar orbiting satellites, they fly closer to Earth, and they give us a little bit of different information. We use these geostationary a bit more often with our weather. We're going to talk more about satellites later on in the summer. But here's an example of what we get from one of those geostationary satellites. It's what we call a visible satellite image. It relies on sunlight reflected off the clouds to actually see it. All right, so this was Hurricane Laura 2 years ago. A really bad hurricane that went into southwest Louisiana and Lake Charles. And then again, like I said, we can actually string these together from our geostationary. This is a loop for Hurricane Ida from last year. And boy, look at how scary that looks, right? Now, the colors, this is not what it would look like from space. The colors on this particular graphic are colors that we've added in with our computers. It helps meteorologists figure out where the worst of the storms are, where the strongest part of the hurricane is. So it wouldn't look like that from space. That's our satellites capturing some images, and then we kind of add some color in our computers to make it look like that. All right, that's going to wrap up our introduction to weather lesson for today. We're going to have new lessons every Monday through the rest of the summer, so for the next 8 weeks. So be sure to check it out. In the meantime, you can also go to our website, wafb.com/capscorner. We've got worksheets and other information there. We even have a coloring book. You guys can go check that out. So be sure to check that out. All right, we're going to hop back into studio now. And anybody that has questions now, we'll take some of those questions. And if you're on Facebook or YouTube, you can pop those questions in the comments. All right, welcome back live. Hopefully you boys and girls learned a little bit from that lesson today. So we'll keep this up, as I said, through the summer. This is the first of 8 lessons we'll be doing every Monday at 10 o'clock. Coming up next week, I forgot to mention there in the lesson itself, we're going to be talking all about hurricanes. So be sure to tune in next Monday at 10 o'clock. So this is the 3rd year we've been doing Caps Corner. And yeah, some of those slides you've seen before. I did try to mix it up and give you some new stuff. 3 new experiments I did there with my girls. And you see, we kind of had mixed results. Some of them went really well, and it's kind of hit and miss. And that's how it goes at home, boys and girls, and that's okay. If you don't get it right the first time, you just keep trying and see if you can get it the 2nd or the 3rd time. I had to tell my girls the same thing. It's okay if it doesn't work the first time. But also want to point out that you can go to our website, wafb.com/capscorner. And coming up later on today, probably later this morning, not only will we have the lessons posted, but I'm going to have a couple of new worksheets posted to go along with today's lesson. If you click on where it says activity pages, this is what I was kind of showing at the end. We've got a bit of some pages you can color, some additional kind of fun worksheets there, so be sure to check that out. But again, that is wafb.com/capscorner. All right, so let me take a peek down now to see if we have any questions. So if you're watching on Facebook, I'll take a minute or two. Thanks to Darlene and Barbara, and I think I saw me on here watching this morning. Appreciate you guys tuning in, and hopefully you learned a little bit. This is going on a couple of different Facebook pages, so just taking a moment to see if we have any questions. But if not, that's okay. Hopefully we covered everything you needed to know. So in the worksheets that will be posted, we'll have a few questions about high pressure and low pressure, about lightning, about a couple of those weather tools that we covered. So one thing I didn't really say in the lesson, boys and girls, I like to kind of, when I go out and do school talks, I like to say very simply, radar shows us rain. Remember that. Radar shows us what? Rain. And I like to say satellite shows us clouds, okay? Radar shows us rain. Satellite shows us clouds. All right, taking one more peek down just to see if we have any more questions before we wrap it up. But again, we'll have new lessons every Monday at 10 o'clock. And if you don't get to watch these, I know a lot of you are watching on Facebook, but these are also on WAFB Plus. So for moms and dads, that's our free app for your Roku, your Fire TV, your Apple TV. We'll also be posting these on our YouTube channel after the fact. So if you want to watch these on a bigger screen and not your phone or tablet on Facebook, you can catch it there on WAFB Plus or on YouTube as well. All right, I am not seeing any more questions. Let me double check. Make sure we're not seeing any questions rolling in. But if we don't get any questions, we'll go ahead and wrap it up. All right, I'm not seeing any questions, so we'll go ahead and wrap it up. And again, we'll be right back here next Monday at 10 o'clock. And next week, it's all about hurricanes. We're in the hurricane season, so we'll help you learn about how hurricanes develop. We'll talk about the names, how that happens, and much, much more. Tune in for Caps Corner Summer Camp next Monday at 10 o'clock in the morning.